This is our last lesson of the semester. We're going to be talking a little bit more about quadratics, mostly because I want you to have a little bit more practice working with these equations. They're definitely going to be on the final exam, and definitely things you're going to see in Math 121. So we're going to look at two different things with quadratics. We're going to look at applications, which we did cover back when we talked about factoring. So again, that would have been near the beginning of the semester. I know applications or word problems are one of the most challenging parts of a math class, so I think it's a great thing for us to review before the final exam. In addition, we're going to take a look at graphing, and we did do a little bit of graphing when we talked about functions. Again, that was very early in the semester, and that's another topic that is going to be important in 121. So let's just start by doing some application problems. Example 1 says a triangle is 10 centimeters wider than it is tall. The area is 48 square centimeters. This should say find, let me write that down, find the height and the base. Okay, so we have some kind of triangle, and it is 10 centimeters wider than it is tall. So if we call the height of the triangle x, 10 more than x would be x plus 10. All right, we're told that the area of this triangle is 48 square centimeters. So first thing I have to do is remember from geometry, or if you don't remember, I'll tell you what it is now. The area of a triangle is 1/2 base times height. So using this formula, that means 1/2 times the x plus 10 times the x has to equal 48. And so there's my equation. 1/2 base times height equals the area. To solve this equation, I think the first thing I would do is get rid of the fraction. So I'd multiply both sides by 2. And now I'm left with x times x plus 10 equals, and I just have to figure out what is 2 times 48. That should be 96. So x squared plus 10x equals 96. This is a quadratic equation. So I've got some options here. I could set one side equal to 0 and try to factor. I could use a quadratic formula, or I guess I could solve by completing the square as well. So it's up to you which method you prefer. I am going to solve this by completing the square, simply because I think it wouldn't hurt for us to see another example of that before our final exam. So if you want to solve by completing the square, you want to make sure the constant is on the right-hand side. That's exactly what I have here. Then you take the number in front of the x, it's a 10, and you divide it by 2. That gives you 5. 5 squared is 25. So to complete the square, I have to add 25 to both sides. Now I'm going to factor my left-hand side. It turns into x plus 5 squared. 25 plus 96 should be 121. So now we can take the square root of both sides. Don't forget the plus or minus. So x plus 5 is plus or minus, square root of 121 is 11. So that means x plus 5 could equal 11. So x would equal 6, or x plus 5 could equal negative 11. So x is negative 16. Now, it doesn't make sense to have a negative answer when you're talking about a triangle and its dimensions. Only the positive answer makes sense here. So back to my picture, we said the height was x. So it looks like the height would be 6 centimeters. And the base should be 10 plus 6, or 16 centimeters. And there's my final answer. Now, again, I chose to solve this equation by completing the square simply because I know there'll probably be a problem on the final where you have to complete the square. And so I thought you could see another example of that. However, it's definitely not wrong, and in fact, it might be faster to try to factor. You could have set one side to 0 and factored, or you could have used the quadratic formula as well. All right, example 2 says we have a picture frame, measures 12 centimeters by 20 centimeters. If 84 square centimeters of the picture shows, so there's our frame, and then inside the frame is the picture, and we know the area inside the frame is 84 square centimeters. Find the width of the frame. Okay, so first of all, what are they asking us to find? They're asking us for this distance, the width of the frame. So we'll call that x. How wide is the frame? So to get our equation, I want to think about if this height is 20 centimeters, what is the height of the actual picture? How much of the picture can show? Well, again, the width of the frame is x, so along all 4 sides. So that means if that longer yellow line is 20, the actual height of my picture would have to be 20 minus 2x. 1x on the top and 1x on the bottom. It's shorter by 2 widths of the frame. The width of the picture, let's see, would be, let's get another color. So here's the width of the picture. We know the width of the frame is 12 inches. So using the exact same reasoning, erase that. The width of my picture would be 12 inches minus 2 x's, 1 for each side of the frame. We know the area inside the frame, again, this area of the picture, has to equal 84. So that means if I take the height of the picture times the width of the picture, that has to equal 84. This is a quadratic equation, so to solve, I'm going to simplify. That means I'm going to FOIL out the left-hand side. 20 times 12 is 240. My outer is minus 40x. My inner is minus 24x. And my last is plus 4x squared. If I combine like terms, I get 4x squared minus 64x plus 240 equals 84. I'm going to set one side equal to 0, so I'm going to minus the 84 and see what I get. 4x squared minus 64x plus 156. And then I think we can actually factor out of 4. I'm going to try to factor out of 4. And let's see, 64 divided by 4, that should be 16. And then 156 divided by 4 is 39. Now I have some choices. I can use the quadratic formula, or I can try to factor. This time I think I'll try to factor. We could also complete the square. 39 is the same thing as 3 times 13. And minus 3 plus minus 13 is minus 16. So that does work. This thing can be factored. My GCF of 4, well, that can't equal 0. But x minus 3 would equal 0 when x is 3. And x minus 13 would equal 0 if x is 13. Now, only one of these answers makes sense. If you go back to our original picture, we said the width of our frame is only 12 inches. So the entire bottom measures 12 inches. So that means this little distance here, one on each side, the x's, well, it can't be 13. That just wouldn't make sense. There's not enough picture, or picture frame, I should say, to have 13-inch widths there. There's no way that'll add up to 12. So the only answer that makes sense in this problem is the 3. You just don't have enough material for 13-inch, or I guess it's centimeter, widths. And that's the number they're looking for, so that's your answer. The width of the frame is 3 centimeters. Okay, I've got one more application. This last application says a rectangular parking lot. So again, I'm going to draw a picture. So I've got a rectangular parking lot is 50 feet longer than it's wide. So I'll call the width x, and then the length x plus 50. Determine the dimensions of the parking lot if at the diagonal it measures 250 feet. So there's my picture. I've got to figure out what x is. In this picture, I actually see a right triangle. So by drawing that diagonal, I now have a right triangle. And I know that anytime you have a right triangle, the Pythagorean formula will hold. So that means x squared plus x plus 50 squared has to equal 250 squared. There's my equation. I'm going to try to simplify, so get rid of parentheses, combine like terms, and then solve. So x squared. We're going to have to FOIL out the x plus 50 squared. It should be an x squared. And then 2 times 50 is 100, so you should get 100x. And then 50 times 50 should be 2,500. So I happen to remember that pattern for squaring a binomial, but you could also write it out and use FOIL. And then finally, 250 squared, that should be 62,500. All right, if I combine like terms, I've got 2x squared plus 100x plus 2,500 equals 62,500. I am going to set one side equal to 0, so I'm going to subtract that 62,500. That gives me 2x squared plus 100x. Let's see, minus 60,000. We can factor out a 2, and then we're left with an x squared plus 50x minus 30,000. We can try to factor this, or you're welcome to use the quadratic formula. 30,000 is kind of a hard number to factor, just because it's so large. I feel like we probably could factor this, but I think even though these numbers are a pain to work with, I think I would use a quadratic formula. So that means my A is 1, my B is 50, and my C is negative 30,000. And I'm going to plug all of that into my quadratic formula. So I took those numbers, I plugged them into the quadratic formula. Again, A was 1, B was 50, C is negative 30,000. And then I went through and I did the math. So 50 squared gave me that 2,500. Once again, we've got the minus and the minus, so that turns into a plus. 2,500 plus 120,000 is 122,500. I used my calculator to find out that the square root of that number was just 350. And so once again, it looks like we've got two possible solutions. Minus 50 plus 350 divided by 2 is 300 over 2, or 150. Minus 50 minus 350 over 2 would be negative 400 over 2, or negative 200. A negative answer doesn't make sense. The only answer that makes sense is the 150. And so that would mean, let's see, the width is 150 feet. And the length would be 150 plus 50, or 200 feet. So when you're solving applications, I think it's a really good idea to draw a picture first. You can look for things like right triangles. That's when you're going to use the Pythagorean formula. You might have to use area of a triangle, 1/2 base times height, or maybe area of a rectangle. Finally, the last thing I want to talk about is just a little bit more about graphing quadratics. We did this when we talked about functions. Quadratics are types of functions. And we did these problems by making tables of values. And that's exactly what we're going to do here. So in part A, I want to graph f of x, give myself a little more room, there we go, equals x squared plus 3. So I'm going to create a table of values, and I like to pick some negatives and some positives. So I'm just going to try -2 to 2. I take these numbers and I plug them into the function. So -2 squared plus 3, that's 4 plus 3 or 7. -1 squared plus 3, 1 plus 3 is 4. 0 squared plus 3 is 3. 1 squared plus 3 is 4. And 2 squared plus 3 is 7. So if I plot those points, let's see, -2 goes with 7, that's all the way up here. -1 goes with 4. 0, 3, 1, 4, and 2, 7. I get that parabola or U shape that we talked about before. And so there's the graph of part A. So I'm not surprised by the shape. Now let's compare that to the graph of B. So x and f of x, I'm going to make a table of values. I'll pick the same x's. So if x is -2, let's see, now we get -2 squared plus 3. That's going to become a -4 plus 3, or -1. -1 squared plus 3. That's -1 plus 3, or 2. -0 squared plus 3 is 3. -1 squared plus 3 is 2. And -2 squared plus 3 is -1. So plotting those points, x is -2, y is -1. So I've plotted those points and I have the same kind of parabola shape to my curve. I do want to point out a couple things as we compare these graphs. One thing I'd like to point out is notice that part A we had a positive x squared, and our graph opens up, our parabola opens up. In example B, we have a -x squared, and our graph opens down. That pattern will always hold when you're graphing quadratics. Now, you don't have to remember that this semester because you'll be asked to make a table of values, and your table will show you that. But sometimes it's nice to kind of have an idea of what to expect when you draw the graph. In addition, the other thing I want to point out is both of these problems had a +3 on them, and the graph starts at +3, 3 units up. Again, that's also not a coincidence. You're going to talk a lot more about graphing in Math 121. I really just want to show you that there are some patterns when you're graphing these equations. So let's do the last one. We're going to do the same thing. We're going to make a table of values. So I'm going to do the x and the f of x. I'll pick -2 to 2 again and see what happens. If I plug those numbers in, let's see, -2 plus 2 squared, that's 0 squared or 0. -1 plus 2 squared, that's 1 squared or 1. 0 plus 2 squared, that's 2 squared or 4. 1 plus 2 squared, that's 3 squared, or 9. And we're starting to get off of the graph paper now, so I'm going to erase that last one. I'm not even going to bother computing that. Instead, I think I'm going to add an extra point. I think I'm going to add another negative number, maybe -3, just so I have a 5th point. You don't have to have 5 points, but I like to have this many so I can make sure I see that right shape. So let's see, -3 plus 2 squared, that's -1 squared, or 1. And so now let's go through and graph these points. X is -2, y is 0. -1 goes with 1. 0 goes with 4. 1 goes with 9. That's off my graph paper. And so with the points that I collected so far, I actually only see half of that curve. And that's another reason why you want to pick some more negative values. So -3 goes with +1. Now I'm starting to see the other half of the curve. So once again, notice we have a positive x squared. The x is positive. And so my curve opens up. This time we had a +2 inside the parentheses. It turns out that actually took our curve and moved it 2 to the left. Again, you don't need to remember this. You're going to be asked to make a table of values. Just plot the points and see what you get. I'm just bringing this up because you're going to do a lot of graphing in Math 121, and you'll learn about all these details there. So that is it. That's our last lesson. Again, the important idea was setting up some applications and then plotting points and making tables and making graphs. So please let me know if you have any questions on this. Look for the final exam review packet. That's probably the best way to study for your final. You can always go through it with tutors. You can talk to me about things that don't make sense. And so that is it for this semester. Good luck, and I hope to talk to you soon.